The next topic on this chapter is colligative properties. Colligative properties. So colligative properties are the properties of a solvent that change when solute particles are added to it. Solute particles are added. If you take a beaker of water and slightly cover it, put a lid on it, and when you come back after 5 days or so this was the water, right? When you come back after some days, after a few days, the level of water decreases and there will be some condensation that you will see on this. What is this because of? Because some of the water has evaporated and here it has condensed. Okay. Now, if some of the water has evaporated, there is some water vapor present here. Okay. So now how does this work? This water vapor, of course this is water vapor, so it's a gas. This is a gas. Gas is a form of water and gases exert pressure. So this water vapor exerts some pressure. Okay. This is known as the vapor pressure. Now when this water sample is not just water, but if it is a solution, the same amount of solution, not water but same amount of solution, and if you had a lid on this, there will be vapor pressure here as well. The vapor will exert pressure, but because this is a solution and not a solvent, this is a solution, some of these surface spots are occupied by solute molecules. As a result, the amount of pressure, the amount of vapor, first of all, the amount of vapor in this case will be less because not all the surface molecules are solvent molecules. Some of them are solute molecules and they don't get into vapor phase. Only the solvent, water, gets into vapor phase. So compared to the previous situation, the amount of vapor is less in the case of a solution. So because of that, vapor pressure is less. Vapor pressure is less compared to the previous situation. So conclude that vapor pressure of solvent, in this case water, vapor pressure of solvent decreased when solute was added to it. When solute was added. So vapor pressure is a colligative property. It changed when solute was added to it. Okay, vapor pressure is a colligative property because vapor pressure of a solvent decreased when solute molecules were added. Osmotic pressure is another one. So if you had two chambers in a liquid sample, if this was, say, sucrose solution, and if this was water, and if this was a semi-permeable membrane, what's a semi-permeable membrane? It allows smaller particles to pass through it, but it won't allow larger particles to pass through it. That means water can move back and forth, but sucrose may not do that because sucrose is a bigger molecule. So what happens? Water flows from here, from this chamber to this chamber, to make the concentration even. So then if you apply a pressure on this solution, it will prevent pressure will prevent flow of water molecule. Pressure will prevent flow of water molecules. Now, this pressure depends on the number of sucrose molecules present in the solution. So if you decrease the sucrose molecules, the pressure will be less, and if you increase the sucrose molecules, the pressure will be more. So osmotic pressure is a colligative property as well. One of the practical applications of this is the storing of blood cells in solutions. Storing of red blood cells. So when red blood cells are stored, you just don't take cells and put them in a bottle. You store them in solutions, and the solution in which the blood cell is stored, so let's say this is the blood cell and this is the solution surrounding it. The solution and the red blood cell have the same solute concentration. Okay. So that means the blood cell is stored in an isotonic solution. Isotonic solution. In this case, what happens is, because there is no concentration gradient, as in the concentration of solute inside the cell is same as the outside of the cell, there is no difference in concentration of the solute. Because of that, the water flow is same. The diffusion of water inside and outside is same. So the cell is not affected by the solution. If the red blood cell was stored in a hypertonic solution, meaning the solute concentration is higher in the solution. Solute concentration is higher in the solution, and it is lower solute concentration inside the cell. What happens is that the water flows out of the cell because there is a concentration gradient. There is a difference in concentration of solution, in the concentration of solute inside and outside the cell. There is a concentration gradient. There is a difference in concentration of solute. Because of that, water flows outside of the cell. So what happens? The cell shrinks. Okay, in a hypertonic solution, water flows outside of the cell. It comes out of the cell, so the cell shrinks. If the red blood cell was stored in a hypotonic solution, hypotonic solution. In hypotonic solution, what happens is that solute concentration inside the cell is higher. Solute concentration inside the cell is higher than outside of the cell. So in such situation, water flows into the cell, and so the cell swells up, and in some cases it bursts. If the water flows really high, the cell bursts. So in a hypotonic solution, cell bursts. So it's very important to store red blood cells in an isotonic solution.